So now let's take a look at some examples. We're required to construct the quadratic equation whose roots are x equals 5 and x equals 1. So what I'm going to do first is say, well, let x1 be 5, one of the roots, and let x2 be 1. And I know that the quadratic equation whose roots are x1 and x2 is given by x minus x1 times x minus x2 equals 0. So what I'm going to do next is replace x1 with 5 and x2 with 1. And that gives x minus 5 times x minus 1 equals 0. Expanding gives x, well, I'll just do it, x squared minus x minus 5x plus 5 equals 0. So I'm just going to simplify this to give x squared minus 6x plus 5 equals 0. So this is the quadratic equation whose roots are 5 and 1. So let's just test our equation. Let's check if these roots in fact indeed satisfy this equation. So what we'll do is compare the left hand side of the equation to the right hand side of the equation. And let's start with the case where x is 5. This was one of the roots. When x is 5, the left hand side is 5 squared. Well, let's write that here. 5 squared minus 6 times 5, which is 30, plus 5. So we have 25 minus 30, which is minus 5, plus 5, which is 0. The left hand side of the equation, when x is 5, is just 0. So the left hand side and the right hand side match. Fine. Let's check the case. Well, let's check for the case when x is 1. When x is 1, the left hand side is, I'll just do that here, 1 squared, which is 1, minus 6 times 1, which is 6, plus 5. And this is 1 minus 6, which is minus 5, plus 5, which is 0. The right hand side is 0. So again, left hand side and right hand side match when x is 5 and x equals 1. So you know for a fact that this equation is such that its roots are x equals 5 and x equals 1. So you know your answer is correct. So always do this quick check if you have time. So here's another example. We need to construct the quadratic equation whose roots are x equals 3 and x equals 3. You know that quadratic equations can have repeated roots, and that's the case where the solutions to that equation are actually the same, like this case. So you know that all we have to do is have a value for x1, the first root, and have a value for x2, the second root, which are the ones we were given, and we just say x minus x1 times x minus x2 equals 0. We expand the left hand side to give x squared minus 3x plus 9 equals 0, which gives x squared minus 6x plus 9 is equal to 0. So you can do, well, let's do the test anyway. When x is 3, what is the left hand side? Left hand side, when x is 3, is simply 3 squared minus 6 times 3, which is plus 9. So we have 9 minus 18 plus 9, which is 9 minus 18 minus 9 plus 9, 0. Right hand side is 0, so we know that this equation is in fact the quadratic equation whose roots are x equals 3 and x equals 3.